Hi folks, I'm in Barcelona and I've just finished a workshop with Klaus Ibsen and Mr. Camel. It was really a nice conference, but I wanted to show you everybody the final part of the workshop because I think it's really interesting. It's the first shop where we have used the saga pattern in Apache Camel, and you will see it's really interesting. So what we built during the workshop was toys shop where you can just buy toys, but it's developed using a microservice architecture, so you have split the logic into different services, in this case a credit service, inventory service and recommendation. These two are stateful, and so this manages the payments and this manages how many items you have in stock. So you may have consistency problem because here, in microservice architectures every service should have its own data storage. So we'll see how to solve them with the saga pattern in Camel. We have a gateway developed in Camel that orchestrates and coordinates all the action done in the other microservices, and it's the main responsible of providing a API for the UI in this case. So you can run all the workshop in Minishift. You can find the code in my GitHub account and Camel workshop repository. So if you want to run it, I will give you also the link. Yeah, let's open the UI. And you'll find the application. You see the recommendation here. What you can do here is to buy items and check out, and then you will see purchases in the inventory system, payments in the credit system. Each item costs $1, so 8 payments correspond to $8. But yeah, there may be problems. I'm trying to do something bad. I opening two screens on the same application. It's not really active, so the application doesn't refresh automatically. So what I do in the first screen is to buy 10 Mr. Camel, and we have 10 only stock. And if you go in the other screen, you still see here 10 Mr. Camel, but if you try to buy 5 Mr. Camel, oops, you have a problem. You can also refresh here, but the problem is that, yeah, you see it here, you have more payments than purchases, and you have spent $23 for 18 items. That's because one of the call that was going to the inventory system failed, but the other call that was going to the credit system was okay, so you spent money for nothing. And you should recover this situation, but it's difficult to do. You cannot rely on distributed transactions and microservices architectures. So how can you solve this problem? Well, Camel has a nice feature called the saga pattern. Yeah, you have here, for example, the order endpoint where you post orders, and you can add here just few lines of code. In this case, I just declare this route as being part of a saga, and I say if something goes wrong, just call this endpoint called cancel order, and cancel order just call the credit system to cancel the payment and the inventory system to cancel a purchase. And I pass a option on this compensating endpoint called order, that is the order that I want to cancel. So this is nice, just few lines of code, and I can redeploy, and we should see a slight difference. Maybe the result will be consistent this time. So I want to show you that the workshop is equipped also with other features of Camel, for example secret burgers and caching. So if you turn off the recommendation endpoint, you see here the recommendation, and if you refresh, you still see the recommendation because they have been cached. So we use secret breakers, so there are delays and failures in that system. We are not affected, the gateway is not affected, and also we cache the result. In this case, we are caching it in Camel Caffeine, but you can offload it also in Hazelcast or Infinispan, Redis, whatever you want. So I am deploying the gateway. You see a rolling deployment that is going on, but in the meantime I restart also the credit by deleting the pod, why I'm doing this, because they are stateful but they're not persistent, so I've reset the situation so that we don't have that inconsistency and we start from scratch again. So let's wait for all the pods to start. Camel has health checks enabled. We have deployed also Spring Boot actuators, and the Fabricate main plugin links the actuator endpoints also for Spring Boot to applications to yeah, OpenShift health checks. So everything is ready now. If we refresh both screens, we should see okay, everything is okay. I don't see the recommendation just because I've restarted the gateway. The cache was in memory, so I cannot see them, and the recommendation service is not running at this moment, but it's not a problem. So what we do, yeah, we can just start it and we will see the recommendation shortly. But okay, this is not the main feature that I want to show. The main feature is this. So I do the same thing that I did before. In one screen I buy 10 Mr. Camel, and in the other screen I buy some Mr. Camel, but also, yeah, you can also buy something else. And oops, oh, you may see what's going on. You may think that this is not a consistent result because you have 16 items bought for $22, so it's inconsistent. But if you refresh, everything has been cancelled asynchronously by Camel. What we have done here was just to claim these 3 lines that say if something goes wrong, cancel the order asynchronously, and that is what Camel did. So asynchronously you have seen that the purchase and the payment has been cancelled. So you have at the end there have 10 items bought for $10, and you can buy something else, whatever you want, but everything here is now consistent. So we got eventual consistency. Eventual consistency is not it's not a bad word. In eventual in Italian mean that, yeah, possibly at the end it will be consistent, but this is not the real meaning. In English it means eventually means at the end for sure everything will be consistent, and this is the semantic of the saga. Camel will take care of it, of calling the compensation if something goes wrong. And we can also use, we have used it in the demo, in-memory implementation. That is a mock implementation, but you can use also real implementation of this pattern that is called LRA, developed by the Narayan team. And it is also compatible with a proposal done in the microprofile spec. You can see, you can look at it. It's called LRA, long running action, and yeah, it is something good for production. And you have this consistent behavior even in microservices, where the logic and also the data is split among different services, and you don't have distributed logs as you have in transaction. It's just a series of messages that flow between these services. So this is a nice feature, and it's kind of unique in Camel. Yes, it's really nice to use. So thank you very much, and don't check the workshop and try to do it. You will find many interesting things that we have developed in Camel. Thank you.